So I think when most people think about this project, they think that these notches here are going to be cut out in the bandsaw and then filed perfectly. And in the old days, that they may have done just that. They wouldn't have used the bandsaw, however. They would use a straight saw because you're never going to get the cut that you want on that bandsaw, particularly with the 1/4-inch blade that we have there. We're going to make these cuts to make them accurate on the table saw, and we're going to be using what's called a DADO blade to cut out those chunks. Okay? A DADO blade is really just a whole bunch of blades that are packed up together to give you a wider cut. Examples of DADO cuts would be like this. So where do we see DADOs a lot? We see DADOs a lot in like shelving, where you would put the shelf into the DADO joint and that would support it on the ends there and give it structure. A lot of times what they'll do is they'll stop the DADO shy of the front so that you don't see the DADO joint in the front there, which makes it a little bit more of a difficult joint because you have a little bit more work to do to square out for the piece that goes in there. But we're going to be using the DADO here to cut out these 2-inch and 1 7/8 pieces for us. So the first thing we do when we work on the blade is unplug the machine and lay the plug up at the top so that visually when you're working on this thing, you can see, and more specifically, I can see as the instructor, that you're doing this safely and that you have the machine disconnected from a power source. This is called a throat plate. This is the thing that had the splitter on it. We have a throat plate with no splitter on it for times we're going with not through the material, but partially through the material that we'd hit that and wouldn't be able to go forward. And we have a throat plate that is used for DADO blades. We also have a wrench, 2 wrenches here for taking this blade off. I'm going to loosen the lock on the blade. I'm going to bring the blade up to its highest point. Okay? This is considered a crescent wrench. And this is considered a box end wrench, right? Crescent looks like a crescent moon, and the box end means that it's entirely encapsulated here with the metal. The crescent wrench goes in the back and connects to the arbor of the blade. And I'm going to turn it forward. This is a right tilt table saw, which means that the nut that's on here, this nut here, is a reverse thread nut. And they do that so that when you're cutting, you're actually tightening the nut rather than loosening it up as you're making your passes. A left tilt blade, and when I say right tilt, this is what I mean, that if I want to tilt it, it tilts to the right. A left tilt would tilt to the left. My one at home is a left tilt, and that has a standard nut on it. This nut costs $21. If I wanted to buy one that had a normal threading or a standard threading on it, it would cost me about 60 cents. The difference is that they don't make a whole lot of these, so like the production is very small, so they charge more for them. So I'm going to turn it in a manner that normally you would think of as tightening the nut to loosen it. Then put your finger over the end of the arbor there so it doesn't drop down the bottom. If it does drop down into the case, into the cabinet of the table saw, it's not the end of the world. We can get it. We can open up the door to the side and get to it. So we can still get that. So don't worry too much about dropping that nut. Then we have what's called a stiffening washer. So that washer is cupped and it tries to keep this blade nice and straight. This blade comes off. All the teeth on this are made out of a material called carbide. Carbide cannot be set on a cast iron tabletop of the table saw here because you can chip the corners off the teeth of this. So we'll set this on the back side of it and we'll get our blades. The ones here that have the teeth all around the outside there and are circular are the outside blades. I have them labeled first and last, but really the way that you would decide that is if we look at this blade, every other blade has that tilt or that angle, the bevel to the cutter. Next one's square tooth, next one's bevel, next one's square, next one's bevel, right? We want the angle to be towards the outsides of the blade. So the first one is the outside right, so we want to be pointed outside right. Remember, the blades are pointed towards us. You know, a lot of people think, well, with safety, you probably want the blades facing away from you. They're not going to cut if you're doing it that way. It has to be towards you because you're advancing the material into the rotation of that cutting. I'll take the last blade and I'll set it aside, not on the countertop, or not on the cast iron tabletop. And then we'll put the chipper knives in. These get put in between the two outside blades. Every blade that we're putting on here accounts for 1/8 of an inch. So if we're doing a 1/2 inch cut, dado cut, we're using 4 blades, right? We have the 2 outsides and we have the 2 insides there, 1/8, 4/8 equals 1/2. For us, we're doing it as wide as we can because we need 1 7/8 and 2 inches. So I can put everything on here and I'm not going to get to either of those. So I'm going to put all the blades that I have on. I'm going to face the carbide towards what I'm cutting. This flat part here that's wider than the blade is the carbide. And that goes on, it gets spaced in between the other teeth there, the other blades, so that can sit tight against. If you have it rotated so that it's against, like this, it can't sit tight, right? So it has to be able to sit flat, tight against. So it has to surround that, so it can go in between like that. And I'll keep putting them on perpendicular to one another so that they kind of work themselves around the circumference of the blade here. Okay, so they're all staggered. Then I'll put on my last blade. And make sure that it's in between and sits tight against the last chipper knife that I have in there. Okay? There's not a lot of arbor left for our washer and our nut, is there? Washer goes on. By the way, this is a lot more easily done when you have the blade all the way up than when you have it down into the table because you're reaching down in too far. Now I'll take my washer, put it on my finger, and then push it over to the threading and turn it in a manner that traditionally you would think of as loosening. Once I have it turned finger tight, I'll put my box end on. And give it a little tightness. We're not trying to wrench down to this thing. One, we disturb the threads on the arbor and the nut by doing that. And number 2, it makes it very difficult for the next person to take this off. Remember, because of the way that the threading works there, we're tightening as we're cutting. So there's not any reason to bear down on tightening up that nut. I would like you to set this blade up yourself. So I would like you to have an understanding of how this goes together and why it goes together like this. Last thing is, we have the protruder part of the back here has to dip down in first, and the whole faces us, and it sits nice and flush with the tabletop. Okay? All right. Next, I'm going to show you how we're going to set it up to cut those dados.